All right, trigonometric equations. There we go. I got it. And solving for sine, cosine, tangent. Today, everything's going to be in a quadratic form, or it will use factoring to separate into two different trig functions. Okay, so in some cases we have, like we know, dealing with Pythagorean identities, stuff like that, that we can have angles or trig functions that are squared or that we need to maybe factor out. Okay, whenever we did identities and things of that nature. So whenever we have a trig equation that is going to be quadratic, all we want to do, just like we did yesterday, where we are going to let our cosine value or our sine value or whatever our function is, like we did yesterday, and whenever we made it, like the letter that I used yesterday was U. Okay, so like in this case, if we let U equal cosine of x, don't let it be the whole function or the squared function, but just let it be whatever our cosine, sine, or tangent value is. So again, I don't care if you use U, I don't care if you use Q, or the fourth letter in your mom's middle name. Whatever letter that is, as long as it's not another X, because that's what we have, it's really up to you as far as what you're going to use. The other thing we have to pay attention to is that we have a certain set of solutions within 0 to 2 pi. Okay? They're not going to be all solutions. So that means basically what it means here is that you will have no 2 pi in. Okay, is all that means. It's just going to be what you have, and you're going to go from there. So if we let U equal cosine of x, then all I'm going to do is just rewrite this as 2u squared plus u minus 1 equal to 0. It just becomes a regular factoring problem. Everything here is going to be factorable. So, and it's going to be pretty easy, pretty light in terms of what you're going to be able to factor. Okay? It's not going to be anything wild and crazy. It's going to be pretty nice and neat. So, if I have 2u squared plus u minus 1, I want to factor this into two parts. So 2u squared, the only option that I have is 2u and u. Signs are different. Need to multiply to give me a negative 1. So I'm going to have a negative 1 and a positive 1 here, because the middle term has to be a positive 1. Then all we do is just now, once we get it to this point, then we're just going to separate everything out. Just like we did whenever you were in Algebra 2 and when you were factoring quadratics, and we did like the zero product property, is now all you're going to do, separate everything back out, and go ahead and let u turn back into cosine of x. So I'm going to have 2 cosine of x minus 1 equal to 0. And I'm going to have cosine of x plus 1 equal to 0. From here, it's up to you. I would just do one thing at a time. So on the left side, I'm going to have 2 cosine of x equal to 1. I'm going to divide by 2. I'm going to have cosine of x equals 1/2. Now, it's really, again, everything how you do it and what order you do everything is really up to you. I'm going to go ahead and figure out what my values are, or when cosine of x is equal to 1/2. Again, if you need to draw the unit circle or use the unit circle to figure out, hey, this is when, remember, or if you want to use your hand, the hand trick, and go like this, and know that whenever I have cosine of 1/2, that's going to be the top side of my hand. So pi over 3. Where else is it also positive, though? Pi over 3 is right. Where's it at? So pi over 3. Where else is it? Okay, it's cosine, so it's positive here, right? So like Rachel said, it's going to be pi over 3. Where else? Down here. What is this? What is the spot down here? Excuse me? 5 pi over 3, I think, is what I was getting. Yeah, that's what it was. Okay. So pi over 3 and 5 pi over 3. Do the same thing, but just do it with the other problem. So I have cosine of x plus 1, so I have cosine of x equals -1. So that one pretty well stops short. And when is cosine, or when is my x value equal to -1? Where is it at? Right there? Not 0. Where is this spot right here? Yeah, it's -1. Where is that spot that I just circled?
Oh.
What angle measurement? Pi. So then, as far as all of my options, all of my spots where this could be true is at pi over 3, 5 pi over 3, and pi. Biggest thing to remember is the reason why we use the u is 2u squared plus u minus 1 is a heck of a lot easier to factor than 2 cosine squared of x plus cosine of x minus 1. It's the same thing, but it's really just, I think it's easier for students to factor the normal way instead of using a trig function. If you don't think you need to do that, that's completely up to you, and that is your prerogative. 6 is a lot like 5, so I'm going to go ahead and go on to 7. Where 7 is 4 sine squared minus 1 equal to 0. Again, we have to pay attention that we have a particular window that we've got to fit everything into. So then, this is one that you can either factor, or you could actually just solve it like normal. Okay? You could leave it, like you could change sine squared, or you could change sine squared of x into, or really sine of x into u, if you wanted to. Okay? There are really two options. So I'm going to give you, so like case 1 is basically like we did before, and just let u equals sine of x and have 4 u squared minus 1 equal to 0. Now, again, from here, it's completely up to you as far as how you really have like a case 1a and a case 1b. If you have 4u squared minus 1, are you going to factor it, or are you just going to solve it? And it really does not matter to me how you do it. Like, do you agree that we could factor this into 2u minus 1 and 2u plus 1 and do it that way? We're just solving a quadratic, right? So we could have 2u minus 1 equal to 0 and 2u plus 1 equal to 0. So u equals 1/2 and u equals negative 1/2. So again, what is u? U is sine of x. So when is sine of x positive 1/2? When is sine of x equal to negative 1/2? Essentially here, what are you going to do? You're going to put every single spot where you have a y value of being either 1/2 or negative 1/2. Right? So regardless if you go with your hand trick or if you go with the circle, wherever the y value is 1/2 or negative 1/2, you can go from there. Remember, sine is the bottom side of your hand, so it's at every pi over 6 value. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If you want to use the unit circle, you can do it that way and still go from there. The other case, as far as getting to 1/2, would have really been just taking 4 sine squared minus 1 equal to 0 and just solving for sine, dividing by 4. Sine squared x equals 1/4. Take the square root of both parts and getting sine of x equal to plus or minus 1/2. And then going with finding your spots as far as when it was 1/2, when it was negative 1/2. Last type then is just using factoring to separate two different trig functions into an equation. So it's the same idea. So whenever you do this, you want to get everything over to one side. Okay, you're still going to have a window. So I'm still going to have the window in terms of 0 to 2 pi. Same way down here at the bottom, 0 to 2 pi. So even if you start with two different parts on two different sides, I want to take the 3 tangent of x and I want to take it over to the other side. So I'm going to have tangent of x times sine squared x minus 3 tangent of x, and it's equal to 0. So again, what can I, you can let, if you want, you can let tangent equal something like be a u, and you can let sine be a v if you want. It doesn't matter. Or you can leave it just as is. I'm going to leave it because instead of changing everything, I'm just going to leave everything and go from there. So what can I factor out of the first term and the second term? So then each part gets set equal to 0. So when tangent is equal to 0 and when sine squared x minus 3 is equal to 0. solve so when is sine x equal to plus or minus the square root of 3? And then tangent is 0. So let's just stay with this one here. What kind of number is the square? How big is the number square root of 3? Remember, if it's sine, it has to be between the window of -1 to +1. What's the problem with the square root of 3 or negative square root of 3? Well, yeah, it's smaller than -1 and it's bigger than. So this one is not possible. Okay? Because it's outside the domain. So we don't even have to worry about this one. Where is tangent of 0, or tangent of x equal to 0? So when is sine, essentially, when is sine of x over cosine of x equal to 0? If you think about it that way. At what two spots? Okay, pi is right, but since it only goes, it stops here. Where is that? Where's 2 pi actually at? It's at 0. Okay, so because technically the way that the circle is drawn, we start at 0 and we never, we just get all the way up to it. Does that make sense? So it's going to go from 0, x is going to be 0, and x is going to be pi.